look at directional bearing. Now, this is not a section that necessarily comes out of our textbooks, but I think it's very important that we cover it. So directional bearing or heading is talking about the northeast, southwest compass layout that you might be familiar with. So in that system, we have north here, east on this axis, south here, and west over here. Now, what's different about this than most mathematical systems is that north is considered 0 degrees. East is considered 90 degrees. South would then be 180. And west is 270. Okay, now you could go opposite of that, but sometimes they could say on a heading of like 100 degrees, and you would go from here all the way, and it'd be 10 degrees past 90. But then there's another way they could write these relationships. They could also say north 25 degrees west. And what that means is you start north, and so I'll pull up, let me get one of these little arrows. You would start north, but then instead of moving clockwise 25 degrees, you would go towards the west 25 degrees. And so we'd get a value somewhere over here where we've moved from the north pole 25 degrees towards the west pole. This would be the same thing as north 25 degrees west. Just the same, you might see it. Another problem where they might say south 32 degrees west. Now if you had that, what that would mean is you'd start at the south pole. Get a different one here, different color. And we would, starting at the south pole, we'd go 32 degrees to the west. And so from here, you would go over 32 degrees, and that's how you would find south 32 degrees west. Typically, when you use a breakdown system like this, you would start at either the north pole or the south pole, and you'd work your way east or west, depending. Now, I have seen it at times where they might say east 10 degrees north, but that is far more uncommon to write it that way. Usually you would start with the poles, north and south, and work towards either the east or the west. But if they did happen to do it that way, what you would do is simply you would start at the east, and then you would go 10 degrees towards the north. And so that would be this system right here. If we went 10 degrees there, that would be east, 10 degrees north, but you would probably actually see it written as starting from the north 80 degrees this way. You could also, so again, I'll just kind of do it with a dotted line here, or dotted arrow rather. You could have that written, since that's 80 degrees, since 10 and 80 make a total of 90, you could say that is the same thing as, not east, I'm sorry, north 80 degrees east. All right, so having said that, let's look at a couple of problems. It says, take north 36 degrees east and convert that to DMS. That's degree, minutes, seconds. And really, we're going to be doing this in decimal degree. Specifically, we don't even have any decimals, so they're kind of one and the same, but we typically work in decimal degree in this class. So I'll just change that. So I would start. Let me get a little axis here. It shows what this would be. We would be starting from the north here, and we'd be working towards the east. And so let me get a little arrow here. If I start north and I head 36 degrees, it'd be something like that. And there's 36 degrees that way. Now, if I wanted to change it to decimal degree, what decimal degree is, it starts from the x-axis. That's the difference here. So we would start from the x-axis. So the east is the same thing as the x-axis, x-axis. And so if we started from here, you would ask yourself, well, how many degrees must that be? The way to figure it out is there is 90 here. So you would just say 90 minus the 36, coming from the other direction. That leaves us with 54 degrees. In decimal degree, the answer would simply be 54 degrees. Now here's one for you to try. I'll leave this up a little longer. You can pause the video to try to solve it yourself.